Hi, on behalf of Clean Code, this is population density interview question from Deloitte. Let's get into it. So the prompt basically reads as this. Your task is to calculate the population density of these cities, round it to the nearest integer, identify the cities with minimum and maximum densities. Pop density should be calculated as population divided by area, and the output should be city, country, and density. So quickly looking at our problem scope here, we see we only have one table, no big deal. We scroll down to look at our table information. 4 columns, areas afloat. All right, great. That's why we're rounding. No big deal. We come look at this little teaser, see what we kind of have in terms of data. We see area does have a 0 value. We see area does have a 0 value. So we need to make a mental note of that as well. But before we get into the problem solving segment, I wanted to take a quick moment to showcase like how you can start differentiating yourself in these interviews with a non-tech firm like Deloitte. So if we think about Deloitte's revenue cycle, Deloitte finds clients that have an issue. Deloitte provides a solution to that issue. So kind of regardless of what segment or industry you're consulting in for Deloitte, that's the basic process. That's how everybody's paychecks get signed and the firm keeps humming along. So while we're solving this problem, in the back of our minds from our company research and preparation for this interview, we need to say, okay, this is question 1. We can't spend forever here, but we do know that we can start to showcase our ability to think and act like a consultant. What do I mean by that? Well, we know that any kind of work we do at Deloitte is eventually going to get shipped to a client. That client, definitionally, by contracting Deloitte, does not know how to do it themselves, or they wouldn't be paying for Deloitte services, which is really your services. So while we're solving this problem, in the back of your mind, be thinking, how can I keep explaining what I am doing and why I am doing it to somebody who doesn't understand code? I promise you, whether that's a technical team member you're interviewing with, whether that's the project manager you're interviewing with, or whether that's like the principal or partner on that account, that will be beneficial. And that's a very quick way to get your name circled and moved on to the next interview. Okay. That being said, let's jump into the notebook and start breaking down this problem and the steps we can take to solve it. Okay, let's go ahead now and work and break this problem down. Let's quickly just go back through and highlight the key parts of this problem. We know we're going to need to do some rounding. We know we need density of the cities. We know we need a minimum and a maximum density. Density needs to be calculated this particular way. And our final output should contain city, country, and density. So kind of like just looking through all the different kinds of things we need, this is what I would call a trench coat problem. Trench coat problems are a little bit different than what I would call standard problems. A standard problem is like, hey, it's really open-ended, do it however you want to do it, but I need this end result. I need to know how many units were sold in May. Standard problem. A trench coat problem is where you have to do a bunch of little steps and then wrap it all together and make it look like it's one standard problem. Trench coat problems are usually identified by the fact that there's built-in functions that will greatly assist you here. And as we go through and identify our helper functions, we can see that. Like we know stock standard, Postgre has a min and it has a max. There's also a round. And part of the round, what we're going to use is a null if. That's going to help us with our zeros. Null if, very quickly, you pass in a column like area and 0. And so then it says, okay, cool. If something's in area and it's 0, we make it null. That allows us to continue our mathematical operations so we don't get a divide by 0 error or we don't get some wacky number that we know should not be correct. So we have our min, we have our max, we have our round. That takes care of that. Density we'll handle a little bit later. And then we come here to this part here. Should contain city, country, density. Now, this is given to us in the problem, but if we look over here in our city's population, our data table, we know we're going to combine these to make density. And then we're going to combine density with these for our final output. Great, fantastic. This is the hint, in my mind, that's supposed to steer you to the fact that you need to use a common table expression or a CTE to solve this. very quickly for the uninitiated, a common table expression basically takes your data set and makes a little tiny partition. And when you pass data in, it can go through and be changed in the partition and then be written to the rest of your data, or data can come up and out of the partition and be changed. Works both ways. CTEs are super useful when you need something to be non-permanent. CTEs are not permanent. What I mean by that is when we use a CTE, as soon as we're done running the function, as soon as the executable is finished, that information is gone. It's not stored. We are not writing to the database in this particular instance. So CTEs are super useful when we need to kind of have lightweight analytics going on in the background. Not so great if you're doing other applications. For what we're doing, perfectly fine. So let's go ahead and write what we want to do. This is going to be kind of what we're thinking of explaining to our interviewer. So, hey, step A, is I want to create a CTE. So we'll write create CTE. Step B is I need to calculate density. I don't think I spelled that right. We'll keep moving. C is we need to round our density. And actually, B2, this is where we're going to put our null if. Cool. So C, round our density. D, we'll say is min. E is max. F, final output. So here we can see, these are our steps. If we go back up to our helper functions, are we using all of our helper functions? Yes. Great. We're using a CTE. We're doing the calculation as they wanted. We have the rounding. We have everything that's been asked for to be done. And so all that's left to do is to take kind of this worksheet and how we've solved it on paper and then go turn it into code. And that part will be pretty straightforward as we're just going to run through A, B, C, D, E, F and see if it works. And then if we need to debug, we kind of know the process we want to take, and it makes it easiest for us to turn this into documentation. All right, I'll see you back over at the editor. Okay, now that we walked through the problem on paper, we know the approach we want to take to solve it. We know how we're going to solve it. Let's go ahead and put some code in the editor and start walking through our non-technical folks why we're doing things this way. So how I would approach this is I would say, hey, first thing, we're going to put in a CTE. A CTE is with density as, is this part right here. The next line, select city, country, because that's where we want to be pulling from. We're going to round our population. Great. And we're going to do a null if area is 0, just in case any 0 values creep in. Things will be great. Null if area 0 as density. Great. Pretty straightforward from our table, the only table we have, where area is greater than 0. Now, why are we doing a null if the where right here says greater than 0? Excellent question. Not 100% sure, but if feet to the fire, I would say it's the order of SQL operations. This is just insurance. I just felt like it would be a good idea. I don't think it materially changes the answer. I'm sure there's SQL purists in the comments who'll tell you it's not necessary. Listen to them, don't listen to them. I think it's just good practice to help your reader understand what you're trying to do. Okay, our next part we want to do, having taken care of the list, is we want to go through, give ourselves a little space, and do our max density. So we're going to say, hey, max density is, we're going to select city, country, density. You see how that's coming back right here. From density, so from our density calculation, where density equals, and then we're going to select the maximum. So that's how we get the maximum for our city, is we just select max. Great. That is pretty stock standard as an SQL analyst. We're going to do pretty much the exact same thing for minimum, except we flip max and min. And this is where having your work order sheet helps, because sometimes, I haven't seen it very often, with the people that I work with. Every now and again, somebody has like 2 maxes or 2 mins, and you're like, hey, what are you trying to do? Okay, great. So now that we have these kind of floaters right here, we need to actually combine them together. So we have them as individuals. Let's go ahead and create a little union, get them together. Life will be grand, and life will be great. So select all from max density, union all, select all from indensity. You know, I did say there wasn't going to be any joinery. It'll hide. There always is joinery. That's SQL. And then finally, we have our wrap up. This is how we're going to be presenting our final output solution to the client. We go ahead and click run code. Line 25. Don't you like the line 25? Oh, I think it's the comma. Let's try that again. Yeah, it was the comma. It's always the commas. So we do the final combined density here. We're good to go. Our thing runs. Check our solution. Fantastic. I've been Spencer Odep. This has been Clean Code. Thank you for watching.